Okay, this video is over the in-class review problems. So anyway, starting off with problem number one, how many atoms are in 5 grams of helium gas? Okay, so if you have 5 grams of helium, I kind of put it up here on the top right here, but you could also write it down. You could write well, you could make a picket fence, but you could start off with like 5.0 grams He in the picket fence. So this box right up here represents the picket fence. All right. Now, one thing that some people are having problems with is you will have these conversion factors written out on the board. They're not in the block format like this, but they're written like this right here. And some people have problems figuring out which way to put them in. Well, anyway, you can think of like this 1 mole equals blank grams of molar mass. You can think of it as the mole can be on the bottom sometimes and the grams on the top, or the grams on the bottom, excuse me, and the moles on the top. So what you got to do is follow the principle of diagonality. And if you have grams here, you have to have grams down here. So anyway, I'm just going to show this video using the mole blocks, and then I'll set up the picket fence here. So if you have grams here, you have to choose the correct conversion factor. Well, you know you got to have grams diagonal, so you're going to pick this one right here and set it up like this because grams have to be, grams have to be diagonal from grams. All right? And so on your picket fence, what you would write is 1 mole on the top. See, like 1 mole, and you want it on the top because you want grams diagonal from grams. Then you're going to put the molar mass for helium on the bottom, and if you look up helium's molar mass on the periodic table, it's 4 grams helium. So there would be a 4 right there, 4 grams. Okay? Now we don't want moles, so we got to keep on going. So what we need to do is choose another conversion factor. Now notice we have moles on the top. That means moles has to go on the bottom. So we can look, and we want to go to atoms. So we look, well, we want moles on the bottom. We're not going to choose the same conversion factor back to back. So this one's out. Okay, so we have this one has moles on the bottom, and this one has moles on the bottom. But we don't want to go to liters, we want to go to atoms. So we're going to choose this one right here. And so on our picket fence, what we'd write is we'd write something like this right here. 1 mole helium equals 6.02 e to the 23rd atoms, because helium is an atom, atoms helium. And then what we would do is we would just do the math, and the answer to number 1 is 7.5 e to the 23 atoms. 7.5 e to the 23. All right. So let's go to the next one, and let's compare this one to the next one. So how many atoms are in 12 grams of water? So first step, write down what the problem gives you. All right, then we're going to look, and we're going to say, okay, we got grams here. We need grams on the bottom, so we're going to use this conversion factor, but we want the grams on the bottom, so we're going to set it up this way right here. Now we got to get the molar mass of water. So the molar mass of water is H2O. There's 2 hydrogens in water, and each hydrogen is 1 gram for a total of 2 grams. There's 1 oxygen, and it's 16 grams. And so 16 grams, 16 plus 2 is 18 grams. Okay, that's the molar mass of water. Okay, now we need to keep on going because it doesn't want moles, it wants atoms. We have moles up here, we have to have moles down here. All right, so we don't want to use this one because that's the one we just used. We don't want to use this one because we don't want to go to liters. We want to use this one because we want to go to atoms. Notice how I keep moles diagonal for moles. Okay? Now, the thing is, water, if you think about water, water is not an atom. You know, like the last problem we said helium. If somebody drew a picture of helium, you could just draw a circle. Helium exists as an atom by itself. But water is a collection of atoms. Okay, you got like 2 hydrogens, all right, hooked to 1 oxygen. Okay, so this has 3 atoms in 1 molecule. So when you do this conversion factor, you write 1 mole, you got to use the molecule as the correct label for that. Okay, so you would label it molecule. Okay, now we don't want to stop at molecules, we want to go to atoms. So if we have molecules here, we have to have molecules down at the bottom. Okay, so we look and there's only one conversion factor. Well, there's actually two, but you wouldn't use the same one back to back. But you need to find one with molecule at the bottom, and that's going to be this one right here. And so you would put that one right there. And then you'd say, well, in one molecule, there are 3 atoms. And then you would do the math, and that equals 1.2 e to the 24th, I think, if I looked right. E to the 24th atoms. Okay, next problem. Okay, number 3. How many liters are in 25 grams of F2 gas, fluorine gas? Okay, so we start off, we got grams here. We have to have grams diagonal from that. So we search for the gram one, that there's only one conversion factor, and we find the one that has grams on the bottom. So we're going to move it right there. Now we got to get the molar mass for F2. So F2 is roughly 19 is one fluorine, but there's 2 of them, so 19 plus 19 is 38. So the molar mass is 38 grams. Okay, but it doesn't want moles, it wants liters. And so we have to look and we find the liter conversion factor. And we know that moles on the top, so we got to have moles on the bottom. So we choose the one with moles on the bottom, or we write it. When you do your picket fence, you're going to write it with moles on the bottom, like this. See, every time, every unit using this method, the same, like grams has to be diagonal from grams. Moles have to be diagonal from moles. You always got to keep that in mind as you do these problems. Okay, so the answer is 14.7 liters F2. Okay, let's go on to the next problem. Okay, now this one I put a few more conversion factors down. Now these conversion factors are only for solutions when something's like dissolved in water. All right, so this says how many grams of NaOH are required to make 800 milliliters of a 1.5 molar solution. So when you get these solution problems, you're going to get 2 numbers. The key is write down the volume first, because this 1.5 capital M is just one of these conversion factors written as molarity. It's kind of written in a more compact form, capital M. Capital M means moles per liter. All right, so when you have a solution, start off with the volume. Okay, now let's look at our conversion factors and see which one we could pick. So see, we have 2 of them, one with milliliters and one with liters. Well, we have milliliters here, so we have to pick one with milliliters on the bottom. So hey, this is the only one with milliliters on the bottom, so we're going to put it right there. Okay, now the next step is it doesn't want milliliters, it wants grams. So we have moles on the top, we need moles on the bottom, and we want to go to grams. So we search, is there a mole to gram conversion factor? Yes, right here. So we're going to pick that one, but we want moles on the bottom, so we have to write it that way. All right, so if you were setting up a picket fence, you just start off with volume 800 milliliters. Okay, now I'm going to have milliliters, so I want the 1000 milliliters on the bottom. The molarity goes on the top, but you don't write capital M because it's actually moles, okay? So that's how I had it in the conversion factor here. Okay, moles have to be diagonal for moles, so you're going to write 1 mole, and we're dealing with NaOH. So you're going to do the molar mass of or NaOH, and it ends up being 40 grams NaOH if you do the molar mass. So then you would do the math, and I got 48 grams. 48 grams of NaOH. Okay, this one, number 5. How many carbon atoms are in 35 liters of C2O4? Okay, so we're starting off at liters. This is not a solution, this is a gas, okay? So that means we're going to use this conversion factor right here. Liters is starting off on the top, so we got to put the conversion factor. So liters are diagonal from liters. So we would change to moles. Okay, but it doesn't want moles, it wants carbon atoms. So we have moles here, we have to have moles down here. All right, so we look, well, we don't want to go to grams, we want to go to atoms. So that means we have to use this one right here. Notice how I keep the moles diagonal from the moles. All right, now this thing, this C2O4 is not an atom. See, it's 2 carbon atoms and 4 oxygen atoms. So because it's not an atom, when you label this, you have to label it what it is. It is a molecule. So you would label this as a molecule right here. But the problem wants atoms. That means we just got to do one more step. We have molecules here, we have to have molecules down here. So we look and we find one with molecules on the bottom, never use the same conversion factor back to back, so we're not going to use that one. We're going to use this one right here. Now, so we got one molecule equals blank atoms. So we just count the atoms in the formula, and so we got 2 carbons, 4 oxygen. 4 plus 2 is 6 atoms. Then we would do, oh, my mistake, I made a mistake, and this is one that a lot of people make on the test. Okay, not 6 atoms, because here's the trick. This one almost fooled me. It only wants the carbon atoms, not total atoms. So we look, how many carbon atoms are in the formula? Well, there are only 2. Whew, I about made a mistake there. Okay, and that is a mistake that people will make on the test. There is a question somewhat like this on the test. Make sure you don't make the same mistake I did there. All right, so the answer is 1.9 if you do the math, e to the 24th carbon atoms. All right, that's it for this video 1 through 5. I'm going to make another video over the rest of the problems.